class today. So today we are going to discuss the next problem in our section of solids. So today we are going to discuss about a cone which is resting on a HP on a base. So of a diameter 50 millimeter and axis 60 millimeter. You can see the detailed question in our description. Okay, so this is about our solid simple question which is given in my problem. So next they have given about a section plane, where the section plane is perpendicular to vertical plane and parallel to a 5 mm and away from one of its generator. So previously we have solved many problems in which if it is perpendicular to vertical plane, it will be given as parallel to or inclined to horizontal plane. But here it is a more typical problem and we know what is a generator. Okay, here I have drawn the simple position of a cone where the base is resting at the horizontal plane. Hence the top view will be a circle and the front view will be a triangle. So what is generator? As I discussed in the basic classes, generators are nothing but the imaginary line drawn. So we obviously know that a cone is created by rotating a right angled triangle. I hope you know this already. I have been taught in my classes. So when I rotate this right angled triangle with respect to this axis, we can create a cone. Okay, so these things are called as generator. For example, A dash to O dash, B dash to O dash, H dash to O dash. All these things are called as a generators. In basics of a cone, only the last two generators of the cone will be in a dot, because all these generators are called as a imaginary. Why it is called as imaginary? Because we are rotating a right angle triangle in order to generate a cone. Hence it is called as a generator. And that is the reason why it is called as an imaginary line. Okay, so now let us discuss how to draw this section plane and how to find out the true shape of this particular problem. Okay, to draw the section plane, see here it is given as parallel to and 5 mm away from one of its generator. So let us take either A dash to O dash or E dash to O dash. So now what I am going to do is I am going to take this A dash to O dash as one of my generator, from where I have to keep my scale which is parallel to A dash to O dash, and I have to measure 5 mm. See, so I have to measure 5 mm like this. You can use your roller scale which is available with you. See here, I simply move 5 mm. So since if I move 5 mm, my cutting plane would be like this. So long dash, short dash, long dash, short dash, and finally long dash. The last end of the cutting plane should be darker. It should be darker, and it should consist of a line with an overhead which insists that it is a section plane. So it can be named as S and P. So to denote it very clearly, let me draw it with another color. So this is my section plane. So it is darker at the end. It should be dark and thick at the end, and it should contain an arrowhead. So now you can notify in this particular problem where else my cutting plane is cutting the object. You can see one over here. You can see one over here. You be very careful. I am keeping a mark only in order to only for your understanding purpose. Okay, I am having a mark here. I am having a mark here, and I am having a point there. See here, this point is cutting at a generator B2O and H2O. This point is cutting at a generator C2O G2O. This point is cutting at a generator D2O F2O. This point is cutting at a generator E2O. You be very careful here. This is cutting at a base side, which is A to H and A to B. So that is very important. Okay, now let us project from the top. So now let us try to project from the top. See here, it is available from A to B and A to H. See here, I simply project it here so that you can see this is B2O. Sorry, this is, it has to become approximately over here. So it will become here. So this is my A to H, and here somewhere it is going to have A to B. So it is going to be in the base. Okay. So where this is available, this is E dash to O dash. Where is E to O? This is my E to O. So you simply project it. I have a point here. Okay, what is the next point? It is available at C2O and F2O. I hope I am right. Sorry, D2O and F2O. So from the top, I try to project it. I have a point here and I have a point here. So what is over here? This point is available in C2O and G2O. Let us come to the at the end. Here what is here? This is B2O and H2O. If I simply project it here, I have a point here and I have a point here. Okay. So now what about a point in the center directrix? We couldn't project the point towards the down. Hence what I will be doing is I will be taking that point towards the lost directrix or a lost slant edge. I can say this. But here I have to say only directrix or generator. Okay. So from where this is E dash to O dash, I am bringing this point to E dash to O dash. Now I use my compass. I will take my compass with the O as a center, the projected point as a radius. I cut an arc here and I cut an arc at the top. So I will be having a point over here and I will be having a point over here. See, I am having a point here and approximately I am having a point here. I am having a point here and then I am having a point here. If I try to connect it, you can see this forms a straight line. This forms a straight line. Then I try to connect it from here. So I am drawing it approximately, but you try to connect it with the points. So this will be your sectioned top view. You try to connect all these points. So you try to project it exactly. It should be perpendicular to my reference line. These lines should be perpendicular to my reference line. It is very, very important. So I have a point here, 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 and I have a point here. So let us name it. And we can do it here. See, I am taking this is a 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay, this is 7. And I will be having a point here, and this is 8 and this is 9. Okay, so totally I will be having 9 points. So just I have been projected. Now let us try to complete which part should be darker. See here, after the cutting plate has cutting the object, only the remaining portion of the object should be darker. You be very careful. You should not draw this directrix as a darker previously, but here my object is going to be only up to here. That I can specify here. Similarly, this part is cut and it has been removed. Hence, my object starts from here. That's all. Okay, so this is the remaining part. After sectioning. Okay, now what I have to do is I have been completed my front view. I have been completed my sectional top view. Now just I need to draw the true shape of the particular problem. To draw the true shape, what we have to do? We have to keep our scale parallel. But before which we have to name it. So here we can have it as a 1 dash, comma 9 dash, and you can take here you are having 2 dash, comma 8 dash. Okay, in the center you are having 3 dash, comma 7 dash. In this particular point you are having 4 dash, comma 6 dash, and finally you are having 5 dash. So you be very careful whenever you are naming. You bring the names from your top view. Now what you have to do is you have to draw an axillary cutting plane which should be parallel to your cutting plane. See here, I am just drawing it parallelly, and then what you have to do is you have to draw perpendicular lines. From each point where it is cutting the object. 1. Okay, 1. So this is my second point, and then this is my third point. Okay, and this is my fourth point, and finally I have this particular point. So just you make it whether it is perpendicular to your cutting plane. So it is very, very important. Once you try it, you try to complete it, and you can extend it to complete your true shape. So this is how I found out the axillary plane, and I'm trying to draw the true shape of the diagram. So in our previous problem also we have identified how to draw the true shape. If the cutting plane is available in the front view, you have to measure from reference line to the bottom of your top view. See here, from here I am going to measure A. I am going to use my compass. From here I am going to measure 1. This is point number 1. Let my point be here. And similarly, see here, from here I need to measure this point number 9. Okay, I have measured. Then I am having point number 8 and 2. So point number 8 and 2. So this is point number 8 and this is point number 2. And then you can see in the center I am having 7 and I am having 3. So I am having 7 and I am having 3. And then you can see from here I am having 6 and 4. I am having 6 and 4. And finally you can see from here I am having 5. From here I am having 5. If I try to connect it, first let me join this and this. First let me join this and this. Okay, then you use your French curve. You try to use your French curve. You try to use your French curve and try to complete the curve. You try to use your French curve and try to complete the curve. Okay, with which I have completed the true shape of the problem. Where this is point number 1, 2, 3, 4, 5, 6, 7, 8 and 9. You obviously know that once the diagram is completed, I need to hatch my sectional top view and my true shape, for which it should be of 45-degree inclined line and it should be very thin. It should not be very darker, it should be very thin. Okay, here I have to use my hatching. There are 3 different angles available for hatching. One is 30-degree, the other thing is a 45-degree, and another thing is a 60-degree. But we will be using a 45-degree to complete our hatching part. So it is one of the important problem what we are discussing over here. Okay, and the hatching to be given over here also. It should be parallel. All the lines should be parallel and it should have a uniform gap. Don't forget. So now I have completed the front view, sectional top view and the true shape, where you have to specify it. So where this is a front view. So this is a front view. So this is my sectional top view and this is my true shape. Okay, with which we have completed a section part of a cone. Thank you.